Hello, I'm Nicolas Usunier, and I'm going to present our work on fast online ranking with fairness of exposure. This is joint work with Virginie and Elvis Dohmatob at Meta AI. We consider a ranking framework that represents online recommender systems. Users arrive one at a time, and the system needs to generate a ranked list of recommendations on the fly. While traditional recommender systems optimize for a proxy of average user satisfaction, which we call user utility here, we consider a more holistic framework where the recommender systems should fairly allocate the exposure of items to users by taking into account the interests of both users and content producers. In this work, we consider exposure of items averaged across users, and the items recommended at higher ranks get higher exposure. Fairness of exposure received a lot of attention lately. We give here 3 examples that we treat in detail in the paper. First, it is sometimes desirable to boost the exposure of small producers to incentivize them to create content and maintain a healthy ecosystem of producers. Second, in order to avoid winner-take-all effects and popularity biases, it has been proposed that the exposure of items should be proportional to an estimate of an index of the overall quality of an item. Third, motivated by some works on audit of job advertisement platforms, it could be seen as desirable to favor a balanced exposure of items to different groups of users defined by sensitive attributes. For instance, ensuring that a job ad receives a balanced exposure across gender groups. Note that the implementation of this criterion incorporates many challenges, since, for instance, the sensitive user attributes may not be available for privacy or even legal reasons. So we study it here only from a theoretical perspective. The main contribution of this paper is to show that in a wide variety of contexts, we can have fairness of exposure for free in the sense of small additional computational cost compared to not considering fairness of exposure at all. We consider a general framework where we see the recommendation problem as a fair allocation problem, and the resource to allocate is the exposure of items to users. In this framework, the fairness objective can be seen as maximizing a concave function of the average exposures of users to items. However, this is a difficult optimization problem because the exposure is averaged across users. This implies that the optimal ranking of all users depend on each other. Our main contribution is a new algorithm that solves this complex optimization problem online. It is very generic as it applies to every concave function of exposures. Its main properties are memory and computational efficiency. A simple sort at each step is sufficient. The overhead compared to a system that does not consider fairness of exposure is then negligible. Importantly, we show that our algorithm enjoys strong theoretical guarantees as its online performance converges to the theoretical optimum in 1 over square root of number of iterations. Our algorithm is called OFFR for online Frank-Wolfe for fair ranking, where Frank-Wolfe refers to a well-known optimization method we build on. We illustrate an example of our algorithm here for balanced exposure. We see that at each step, it is sufficient to compute 1 score for each item and perform a top k-sort operation. The algorithm has similar computation cost as the standard pipeline of computing a score for each item and then sorting. We present experiments that show, in particular, that the online algorithm converges faster at the beginning than an offline counterpart, which shows its potential efficacy. Please see the paper or the long presentation for more details.